Hey folks, welcome to this section where we'll explore the key components that make up a computer system, from the tangible parts you can touch to the unseen software running behind the scenes. In this video, we'll have a brief overview of these components, and in the upcoming videos, we'll dive deeper into each of the mentioned components. Let's start with hardware. It is the physical and tangible component of a computer. If you can touch it, it's hardware. Examples of computer hardware include case or chassis. It is the protective enclosure that houses all internal components. CPU, the central processing unit. It is the brain of the computer that processes all tasks. Monitor, mouse, keyboard. These are some input and output devices which are used for user interaction. Storage devices like hard drives, SSDs, and external storage for data storage. Graphics card and sound card enhance visuals and sound quality. Motherboard, the main circuit board connecting all the components. Speakers and peripherals, the additional hardware accessories for enhancing functionality. If someone asks what is computer hardware, just remember this. Anything you can physically touch in a computer is hardware, and anything you cannot touch is software. When talking about hardware brands, you might say, I use a Dell, HP, or Sony computer, referring to the manufacturer of your hardware. Unlike hardware, software cannot be touched. It consists of instructions that tell the hardware what to do. The most critical software in a computer is the operating system. Without an OS, hardware is just a non-functional box. A few functions of an OS include task scheduling. The OS manages different operations and multitasking. Application execution. It runs programs like browsers, editors, and games. Peripheral control manages devices like printers, USBs, and external storage.
Examples of operating systems include Windows, Mac OS, Linux, and Unix. And mobile operating systems include iOS and Android. Let's have a high level look at how an OS works. Imagine you have a smartphone. At the base, we have the hardware, the phone's processor, memory, and storage. The operating system acts as a bridge managing communication between the hardware and apps. Application like WhatsApp, YouTube, or Chrome run on the OS using its services to function. You, the user, interact with these apps to send messages, watch videos, and browse the web. Just like this, an OS helps manage everything on a computer, ensuring smooth interaction between hardware, software, and users. Application software runs on top of the operating system and allows users to perform specific tasks. Examples of application software include the Microsoft Office suite containing Word, Excel, PowerPoint, and more, and web browsers like Google Chrome, Firefox, and Safari. Let's understand the difference between software and application. Software is a broad term covering all programs that run on a computer, while application software is a specific type of software designed for a user function. For example, Windows OS and Microsoft Excel both are software, but only Excel can be termed as an application. Networking connects multiple devices to share information and resources. Without networks, computers would operate in isolation, unable to access the internet, send emails, or share files. There are a lot of network connections. Some include direct connection or local communication. That is when two computers are connected via a crossover cable. Local area network or LAN for short. It is when multiple computers in an office or home are connected through a network switch. The Internet. It is a vast network, sometimes referred to as a network of networks, that connects computers all over the world. Every networked device needs a unique identifier called an IP address to ensure data reaches the correct destination. IP addresses are similar to home or office address. It allows packages to be delivered at the right destination. Let's understand what a database is. A database is an organized collection of structured data stored electronically for efficient access. Databases provide a lot of features over a traditional storage system. For example, efficiency. It handles large data volumes better than spreadsheets, and it has faster data retrieval, which allows us to quickly search for specific records. It is space optimized, that is, it stores data very efficiently. and data relationships. It uses SQL or structured query language for managing complex data. Real life database applications include social media, banking systems, e commerce, finance, and more. Computer data storage or digital data storage is a technology consisting of computer components and recording media that are used to retain digital data. Internal storage refers to the storage built into the computer, like RAM, while external storage, like USB drives, external HDD, or SSD, are for backups and portability. Enterprises require better, reliable, and efficient data storage solutions. They generally use something like the RAID, redundant array of independent disks, or SAN, storage area network, and NAS, network attached storage. These are scalable network storage solutions specific to enterprises and businesses. Instead of running one OS per physical server, virtualization allows multiple OS instances to run on a single machine. Benefits of virtualization includes maximized resource utilization, cost efficiency, and flexibility and scalability. In the past, users tried dual booting, where they installed multiple OS on separate disk partitions. However, only one OS could run at a time. With virtualization, multiple OS can run simultaneously, sharing the same physical resources efficiently. In simple terms, virtualization makes computing more efficient, flexible, and scalable. It's a fundamental concept in cloud computing and modern IT infrastructure. Cloud computing refers to the on demand availability of computer resources, such as data storage and computing power, without direct active management by the user. Instead of maintaining physical servers and hardware, companies can rely on cloud service providers to handle these tasks remotely. Cloud services are typically hosted in data centers and accessed over the internet. A data center is a facility where IT resources such as servers, networking gear, and storage devices are housed and managed. In a traditional on premises data center, an organization needs servers managed by hardware technicians, operating systems maintained by system administrators, applications managed by application administrators, networking devices like routers, firewalls, and switches managed by network administrators, and storage solutions managed by storage administrators. Managing a data center requires significant investment in infrastructure, manpower, and maintenance. With cloud computing, the entire hardware and software infrastructure is managed by cloud providers. These companies operate data centers worldwide, making services available to users on demand. As a user, you only need to focus on managing your applications and data, while the cloud providers take care of server and OS management, storage and networking, and security and maintenance. This reduces costs, improves scalability, and increases accessibility. Some of the leading cloud providers include Amazon Web Services, Microsoft Azure, and Google Cloud Platform. Cloud services can be categorized into three main types: public cloud, which is managed by third party providers and available to multiple organizations. Examples include AWS, Azure, or Google Cloud. Another category is private cloud. It is used exclusively by a single organization for greater control and security. And the hybrid cloud is a combination of public and private cloud solutions. IT security, also known as computer security or cybersecurity, refers to the protection of computer systems, networks, and data from unauthorized access, theft, or damage. The goal of IT security is to prevent unauthorized access to sensitive information, protect hardware and software from cyber threats, and ensure service availability by preventing disruptions. A security breach can have serious consequences, including data theft, financial loss, and reputational damage. Cyber threats such as malware, phishing, ransomware, and hacking continue to evolve, making security a top priority for businesses and individuals. IT security involves multiple layers of protection. Organizations implement various security measures such as firewalls to filter traffic, antivirus software to detect and remove threats, encryption to secure data, and access control mechanisms to restrict user permissions. We have covered brief introduction to each essential component of IT. With upcoming videos, we'll dive deeper into each component, starting off with the hardware.